Good morning, everyone. My name is Cynthia Nasiri.
My name is Jada Satchel.
And my name is Janelle Hanley.
Our project today is energy storage devices.
Project goals include to design and run experiments to distinguish between batteries and supercapacitors, measure the charge and discharge characteristics of batteries, and participants will learn about applications, principles, and types of batteries using analog device kits. Python is a program used to measure the discharging and charging characteristics of different types of batteries. Primary batteries, such as alkaline batteries, were fully discharged and their voltage capacity were analyzed. Secondary batteries, such as lithium-ion batteries, were analyzed to study their ability as to how well they are able to operate in terms of overcoming resistance when discharged, as well as how well they are able to hold current when they are recharged. Experimental results were obtained using the analog device kit ADAL 1000 and further analyzed using Excel. Also introduced high school students to electrical engineering concepts and applied these learned concepts to everyday life. The methodology that we utilize would be in finding materials, creating codes, and building circuits, as well as collecting data in Python and analyzing results in Excel. The biggest challenge that we face in this project would be in setting up of the computer environment for the first project, battery explosion, and losing data because the computer went on sleep mode.
The first picture shows the charge setup, while the second picture shows the discharge setup. In the charge setup, we don't need a load, while in the discharge setup, we need a load. During discharge, energy from the battery is transferred to the load, which heats up the resistor, and the heat energy is dissipated in the air. In any real application, once the voltage is at 1.5 volts, the battery is dead. During charge, energy from the charger is converted into chemical energy, which is stored to do some kind of work. This slide shows the results of the COM battery, and the specifications of the COM battery indicate that it has a maximum capacity of 30 milliamp hours. The total charge capacity gotten was 28.25 milliamp hours. We had an initial charge capacity of E, which we don't know about. Then we charge at 1.25 milliamp hours, discharge at 6.8 milliamp hours, charge again at 18.5 milliamp hours, and discharge again at 2.6 milliamp hours, and charge again at 17.9 milliamp hours. Total should be 30 milliamp hours, but since we don't know the value of E, we assume that when it's added to 28.25 milliamp hours, it amounts to 30 milliamp hours. This slide shows the discharge results of the 3-volt lithium-ion battery of 1,000 milliamp hour capacity. The first picture shows the graph of the voltage, which is meant to show 3 volts, but we assume that we lost some voltage during the experiment. The second graph shows that we had a 1 amp hour capacity, and 1 amp hour is equal to 1,000 milliamp hour.
And then with my data, with the current at 20 milliamps, 10 milliamps, and the 3 milliamps, it wasn't enough to charge the battery to its full capacity. But my graph still agrees with the battery specification that it should be charged ideally at the 1 milliamp data point. So the charge at 1 milliamp was better than the rest of the charges at the different milliamps. While my discharge data, all of the batteries discharged fairly well, except for the 20 milliamp data, where it did a little hiccup in the beginning, but it still discharged at a shorter rate than the rest of the batteries. And then this is a demonstration on how all 3 of us discharged our batteries for the experiment. Hi guys, my name is Jada Satchel and I am going to take you guys through my wonderful process on how I discharge a battery, most specifically a AA battery. First, we plug in the computer and then we plug in the analog device, and you'll know the analog device is plugged in when it glows red, like that. And then we take the CHA channel and the GND and we plug in the green wire to the CHA, which means the positive side. And then we plug in the red wire into the GND, which shows the negative. And then we add in the green wire on the same column as the resistor and the other green wire. And then we also do the same with the red wire. It has to be in the same column or else the resistor will not work for this discharge. And then we have to take the battery and plug in the red and green clips. Well, you could use a big clip if it fits around the battery, or you can use a rubber band like how I'm using right now. And we have to rubber band the battery first. Takes a little bit. And then after we put the rubber band over the battery, we take the green wire and plug it to the positive side, slide it under, and then we take the red wire and then we slide it under the negative side of the battery. So now we are in the code and we have to bring up the command prompt to type in our code. And once we put our code through, we can then start the program. So I did a little test run, and now we're going to plug in the resistor into the board. So when I first started the discharge experiment, it was on Monday, July 20th, around 11:30, and those are the results around 4:41 the Tuesday after. Alrighty, so we came back downstairs, and it is 11:17 p.m., and we have completed our discharge experiment. I don't know what happened between the 1 and the 2. But we'll figure that out. But this is the end of our discharge experiment. And then we press Control C, and then that stops the program.
The lessons and activities that we will be sharing with our high school students is where we will be utilizing cross-curriculum studies from classes such as environmental science, physics, and computer science to accomplish the goals of understanding the use of programming language to measure and analyze data, study the logistics of electrical energy and energy storage devices such as batteries, and learn the human impact of energy storage devices as it relates to the real-life scenarios and solving problems. The lessons and activities that we'll be utilizing in computer science is to allow the students to learn and implement programming language from Python in their computer science class. Students will examine and become familiar with features in Python as they also learn about coding. In their physics class, students will utilize and learn about electrical energy, electrical circuits, batteries, volt, ampere, and we will also introduce capacitors and supercapacitors in this unit. Students will also build electrical circuits to help facilitate the learning of the components of a circuit. In environmental science, Students will utilize their class to learn about energy storage, usage, and conservation, and how it affects humans during the Human Impact Unit in the environmental science class. Students will also research different ways energy, batteries, capacitors, and supercapacitors are used in everyday life. Students will research products such as cell phones, Tesla products, solar panels, and how they incorporate the use of electrical energy storage.
In future, we aim to create a medium to store power, as well as a phone application or web application to monitor the power conserved, and the device would have to be rechargeable as well.
And these are our references. So thank you guys so much for listening to our presentation. And my name is Jada.
My name is Cynthia.
And my name is Zanel Hanley.
And we hope that you guys have a great day.